Good evening. Very happy new year to all. Let us discuss about length of tangent. Actually, it should be length of tangent segment. Tangent is a line which has no length, but by length of tangent we mean length of tangent segment. Show that the length of tangent segment to the circle. See, this circle is considered because from this we can obtain formula for length of tangent segment to standard circle also, right? So show that the length of tangent segment to the circle x square plus y square plus 2gx plus 2fy plus equal to 0 from the point px1 y1 outside it, and we have to show that it is root of x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Now a good student will appreciate this. See, we have already discussed about S notation, capital S. So the left hand side is x square plus y square plus 2gx plus 2fy plus c, that is S. Replace x by x1, y by y1, you get S1. So can I say that length of the tangent segment is root S1, and that is why we discussed S notation, though it is not part of the syllabus. Now proof is very simple. For this circle, what is the center? It is minus g minus f. And what is radius ct? It is root g square plus f square minus c. So pxy is any point outside the circle. Okay. So by the distance formula, cp square is this. Now triangle CTP is a right angle triangle at T. Hence by Pythagoras theorem, I will show this diagram again. See, what is PT square? It is CP square, which is obtained by distance formula, less CT square. CT happens to be the radius, right? So substitute the values. You will get PT square as what? X1 square plus Y1 square plus 2gx1 plus 2fy1 plus c. So what is PT? Root of that, right? Notes: if the equation of the circle is given in this form, then obviously we have to divide by a, and then we can use the formula. The length of the tangent segment to the circle x square plus y square equal to a square drawn from the point p x1 y1 will be what? Root of x1 square plus y1 square minus a square. Okay, so this is about length of the tangent segment. Sum number 14. Find the length of the tangent segment drawn from the point phi 3 to the circle x square plus y square plus 10x minus 6y minus 17 equal to 0. We can use ready-made formula. It is root S1. What is S1? Expression obtained by replacing x by x1, y by y1 in the equation of circle. Now here tangent is drawn at x1, y1, which is phi 3. Simple. So replace x1 by 5, y1 by 3. 2g is 10, coefficient of x. 2f, coefficient of y, minus 6. Constant term as it is. So if you simplify, you get 7 unit. 15th one. Find the value of k if the length of the tangent segment from the point 8 minus 3 to the circle x square plus y square minus 2x plus ky minus 23 equal to 0 is root 10. So use the formula, equate that with root 10 square. On simplification, you get k equal to 8. 16th and 17th for homework. These are the answers. Sum number 18. Find the equation of the tangent to the circle x equal to phi cos theta, y equal to phi sin theta at the point theta equal to pi by 3 on it. You have to be very careful because in the last sum, it was x equal to a sin theta, y equal to a cos theta. Remember, x equal to a cos theta, y equal to a sin theta are the parametric equations of which circle? X square plus y square equal to a square. Now these are parametric only. So I can say a equal to phi. So what is equation of tangent at p of theta? X cos theta plus y sin theta equal to a. A is phi, theta is given to be pi by 3. Cos pi by 3 is half, sin pi by 3 is root 3 by 2. On simplification, you get x plus root 3y equal to 10. Sum number 19, this type is important. Show that line 2x plus y plus 6 equal to 0 is a tangent to the circle x square plus y square plus 2x minus 2y minus 3 equal to 0. Find its point of contact. Now, if only first part is asked, that is, show that line is tangent to the circle, in that case, we will use different method. See, a line is tangent to the circle if length of perpendicular drawn from the center to the line is equal to radius of the circle. So why not to use this method in this sum? Because to get the point of intersection, again we'll have to consider it as HK, obtain two equations and so on. So we use this method. From the equation of line, what is y? Minus 2x minus 6. Put this in equation of circle. You get a quadratic equation. Why quadratic? Because its two roots are the 2 points in which given line cuts the circle. But you will notice that in this case, 2 points are not distinct. They are identical. Why? Because what are the roots of this quadratic equation? First root is minus 3, second is also minus 3. So the conclusion is line cuts circle in two not distinct but coincident points. Such a line is called as tangent. See the advantage. We are asked to find the point of contact. We have already got x coordinate of point of contact. It is minus 3. So what is y coordinate of point of contact? Put x equal to minus 3 in 1. See, this is 1. Okay, so you get y as 0. So what is the point of contact? Minus 3, 0. Sum number 20. If the tangent at 3 minus 4 to the circle x square plus y square equal to 25 touches the circle, another circle, x square plus y square plus 8x minus 4y plus 6 equal to 0, find the c. Simple one. First, this is standard circle. So what is the equation of tangent? It is 3x minus 4y minus 25 equal to 0. Now this line is tangent to the given circle, right? So length of perpendicular from center of the circle to this line, tangent line, must be equal to radius of the circle. So one equation, only one unknown, which is that c. Get the value. Now this is tangent to the circle x square plus y square plus 8x minus 4y plus c equal to 0. Now for this circle, what is the center? Small c is used, so it is better that we use center by m. Minus 4, 2, and what is radius? Root of g square plus f square minus c. So root of 16 plus 4 minus c, that is root of 20 minus c. Now length of perpendicular from center on tangent is radius of the circle. Use formula for length of perpendicular, mod of ax1 plus by1 plus c upon root a square plus b square, where x1 y1 is point from which perpendicular is drawn, center 4 minus 2. I'm sorry, minus 4 2, right? So substitute the values. Mod of minus 45 by 5, that is mod of minus 9, that is 9. But it is root of, this should be uh, 20 minus c. So square to get 81 equal to 20 minus c. So what is c? C is nothing but minus 61. So minus 61 is the final answer. 21st, find the equations of the tangents to the circle x square plus y square equal to 16 with slope minus 2. Now you have to use standard results. Tangents to standard circle in terms of slope m are what? Y equal to mx plus minus a into root 1 plus m square. For the given circle, radius a is 4. M is given to be minus 2. Just substitute the values. You can also write answer as 2x plus y minus plus, same as plus minus. So 2x plus y plus minus 4 root 5 equal to 0. Same thing. 22nd, Find the equation of the tangents to the circle x square plus y square equal to 4, which are parallel to 3x plus 2y plus 1 equal to 0. Actually, it is similar to 21st sum. The only thing is here slope is not given directly, it is given indirectly. So from the equation of circle, you get A. What is the slope of the given line? Slope of the line is negative coefficient of x upon coefficient of y, provided terms in x and y are on the same side. So here it is minus 3 by 2. Same is the slope of required tangent. Why? Because it is parallel to above line and parallel lines have the same slope. So m is minus 3 by 2. Substitute. So y equal to minus 3x by 2 plus minus 2 into root of 1 plus 9 by 4. On simplification, you get equation of tangent as rather tangents as 3x plus 2y equal to plus minus 2 root 13. 23rd. Find the equations. This is actually for homework, but I'll read the sum. Find the equations of the tangents to the circle x square plus y square equal to 36, which are perpendicular to the line 5x plus y equal to 2. Same logic, a equal to 6. Slope of the given line is minus 5, right? Required tangent is perpendicular to it. So its slope is 1 by 5. So a equal to 6, m equal to 1 by 5. You should get this answer. Sum number 24. Let me explain. Find the equations of the tangents to the circle x square plus y square minus 2x plus 8y minus 23 equal to 0 having slope 3. Actually, this is not standard circle because ready-made equations are available for x square plus y square equal to a square. So what should be done here? Let the equation of the tangent with slope 3 be y equal to 3x plus c. That is 3x minus y plus c equal to 0. Now center of the given circle is 1 minus 4. And what is radius? Root 40. Since line 1 is tangent to the circle, length of perpendicular from the center to this line must be equal to radius. As modulus is there are two values. So there are two such circles. C, first value of C is 13. Second is minus 27. So there are two tangents, I mean not circles, there are two tangents, 3x minus y plus 13 equal to 0 and 3x minus y minus 27 equal to 0. Then 25th, find the equation of the locus of a point, the tangents from which to the circle are at right angles. You should be able to tell me answer directly. Yes, you guessed it right. It is x square plus y square equal to 2 into 9, that is 18. Do you remember that result? Locus of points, tangents from which to the circle x square plus y square equal to a square are at right angles is again a circle x square plus y square equal to twice a square. It is called as a direct circle. So you will definitely ask me, sir, can we write this directly? If asked for 1 to 2 marks, yes, but usually this is asked for 4 marks, so you have to prove this. The radius of the given circle is 3. Let P x1 y1 be a point on the required locus and M be the slope of tangent drawn from the point P to the circle. Note the tangents to standard circle y equal to mx plus minus a is 3. So 3 root 1 plus m square. Since tangents pass through x1 y1, y1 equal to mx1 plus minus 3 root 1 plus m square. Same logic. Shift this term to LHS, square and so on. Actually, you should remember this. x1 square minus a square m square minus 2x1 y1 m plus y1 square minus a square equal to 9. The only thing is a square in this case is 9. The roots m1, m2 of this quadratic equation are slopes of the tangents that can be drawn to the circle from the point P. Now product is constant term upon coefficient of square term. But tangents are at right angles. So equate m1, m2 with minus 1. Rearrange the terms. Rearrange the terms to get what? x1 square plus y1 square equal to 18. To get equation of locus, we replace x1 by x. y1 by y to get equation of locus as what? X square plus y square equal to 18. A good student is supposed to write this is called as director circle of the given circle. Okay. So this is for sum number 25. Now 26th is again interesting. It is lengthy because three parts are asked. Tangents to the circle x square plus y square equal to a square with inclinations theta 1 and theta 2 intersect in P means what? Tangents are drawn from the point P. Find the locus of P such that first part tan theta 1 plus tan theta 2 equal to 0. Second, cot theta 1 plus cot theta 2 equal to 5. And third part, cot theta 1 into cot theta 2 equal to C. Let P x1 y1 be a point on the required locus. The equations of tangents with slope m to the circle x square plus y square equal to a square are y equal to mx plus minus a into root 1 plus m square. If these pass through P x1 y1, coordinates will satisfy the equation. Same thing. Rearrange the term square. You have to remember this equation. Now next part is interesting. The roots m1, m2 of this quadratic equation in M are the slopes of the tangents drawn from P. Now sum of the roots is negative coefficient of M upon coefficient of M square. Actually, I should not say coefficient. I should say multiplier, because when we obtain equation of locus, we treat x and y as variables. What is product? I should say term free from m upon multiplier of m square. Is that clear? Now this is the most important part. Theta 1 and theta 2 are inclinations of the tangents. So you should know that tangent of inclination is nothing but slope. So tan theta 1 is m1 and tan theta 2 is m2. You have done this part in quadratics. Now first part, tan theta 1 plus tan theta 2 is given to be 0. That is m1 plus m2 is 0. But m1 plus m2 is this. So x1 y1 equal to 0. So what is the equation of locus? xy equal to 0. Now can you tell me what does xy equal to 0 stand for? I'll give you 2 minutes. Second, cot theta 1 plus cot theta 2 is 5. That is 1 upon tan theta 1 plus 1 upon tan theta 2 equal to 5. Substitute, rearrange the terms. m1 plus m2 is known, m1 m2 is known. On simplification, you get locus as 5y square minus 2xy equal to 5a square. Last part, cot theta 1 into cot theta 2 is given to be c. That is 1 by tan is c. So what is m1 m2? 1 upon c. But m1 m2 is y1 square minus a square upon x1 square minus a square. Equate. To get equation of locus as what? As x1 square, I'm sorry, x square minus a square equal to c y square minus a square. Is that clear? Now about this, what does this represent? This is combined, that is joint equation of coordinate axis. Actually, we'll be studying this in 12th standard in the topic pair of lines. What is the equation of y-axis? X equal to 0. What is the equation of x-axis? Y equal to 0. Join them, combine these two equations to get xy equal to 0. Of course, this is not expected of you. You need not even write this in exam that xy equal to 0 is the combined equation of or joint equation of coordinate axis. Is that clear? So here the topic circle is over. In the next lecture, we'll be doing conics.